All right, then, 6.8 applications of distance and midpoint. Distance has a lot to do with square roots. Midpoint, not so much, but whatever. Lots of fractions, I guess.
Great.
All right, so we come back to the Pythagorean theorem, which you saw if you took 950 or 920, you saw that there. If you took 990, you saw it there. But now we're going to see it again for distance, which is another nice way to use the Pythagorean theorem. When we'll use this in life, I don't know. Probably never, because calculators will do it for you and computers. But you can do it by hand hopefully after this lesson. So the parts of this is a right triangle right here. So this only applies, the Pythagorean theorem only applies to right triangles. And you know it's a right triangle because right here, this is usually the marking for a right angle. So it would be 90 degrees, if that matters to you, okay? Pretty much if it looks like an L, I guess, right here, then you know it's 90 degrees-ish. But if you're using the Pythagorean theorem or the distance formula, which we're going to be seeing today, then you know that it is a right triangle. So, as it turns out for the Pythagorean theorem, these two parts of the triangle are the legs, and if you were to take those two legs and square each of them and then add them together, it'd be this side length right here, which is the hypotenuse. That's always the opposite of the right angle, okay? So if you're ever not sure which of the parts is which, see the right angle right there, which may not show all the time, but the two parts of the triangle that make up the right angle are always the legs. The other side, and I kind of look at the 90-degree angle like it points at it, it's pointing at the hypotenuse. And yeah, there's a Key and Peele skit that goes over, it's pretty good. But if you take those two legs and square them, add them together, boom, you get the hypotenuse as a square. Mathematically, of course. So usually these would be numerical. This is kind of very abstract right there. You may have heard of it more famously quoted as a squared plus b squared equals c squared. I don't know why that makes math people seem very smart. We have much more nefarious ways to make us look smarter than we are, but people buy this one as well. So, oh, it is very nefarious. So, but again, principles of equality will apply, and same with kind of order of operations to solve this stuff. The Pythagorean theorem is named after Pythagoras, who has some interesting history, but I'm not going to go into it because it's pretty nerdy. So Pythagoras was kind of like the king nerd back in ancient Greece. Like, if you can think of being wanting to be the king nerd, he was the man, right? Now, back in those days, he wasn't Chuck Norris because he wasn't there yet, but
He was like the Borat of math.
so the Greeks, for some reason, they loved math, right? Like if you were like, dude, we're going to get together tonight and we're going to party by doing some math, they'd be like, I'm there. What time is it at, right?
I'll run.
No, they would put posters on the street corners and be like, hey, come to our math triangle solving party. And people would be like, are you serious? No way, it's tonight? And they'd show up, man. Well, Pythagoras and his group, they got so big, and like I said, he was kind of the king nerd, that when you get enough of a gathering and a following together, eventually you do accumulate quite a bit of power. And they used it for maybe not such nice things. In fact, once you get power, you can't be questioned. And so one guy questioned Pythagoras on a thing. And so when you have that much power and someone questions you, you have to kill them. So Pythagoras did, by the way, with his own bare hands, takes him and then drowns him. And history has proven, though, that Pythagoras actually was wrong. So just don't mess with math. See what I told you about math people? When they throw a fit, it was a square root thing. But math people, when they get mad, it's, like I said, usually it's not very threatening, but I guess with Pythagoras, he would choke you out, man, in water, which is a bad mix. So there you go. All right, well, this brings us to this right triangle. Oh, they've shown us the right angle. That's nice. So we know that the two sides that make up that right angle are the legs. That's a leg, and that's a leg. Well, I forgot to mention, why do they call these legs? I don't know. Maybe to math people, it's like, look at that sexy leg right there. I don't know. I couldn't tell you. But that's what they call them, legs. Okay, so I'm gonna say the first leg is the x and the other leg is 10. And so we know that this one is, hypotenuse is 12. So I'm gonna square these, all of them. And if I add the two legs as squares together, I should get the hypotenuse as a square. This right here is just an equation to solve. And I know that 10 to the power of 2, 10 times 10 is 100. And I also know that 12 times 12 is 144. If you don't know those things, your calculator does. And I recommend using a calculator. In fact, maybe I should have, because I get this stuff wrong sometimes. But again, this is just an equation to solve. So I'm solving right now for x squared. And so I'm going to subtract 100 from both sides. Now this will just give me x squared, which isn't the solution. That does zero out the 100, and this gives me 44. Last thing I got to do now is just square root both sides, and that would give me the x, right? So it's a square root of 44. Put that in the calculator, you get 2 square root of 11. They didn't label this one with like inches or anything, so just units is fine. I'm just going to say 2 times the square root of 11. Yeah, that's a good point. If this had said up here, hey, make a decimal approximation, then we would have put this in the calculator. It would have given us the decimal, which we would have then put in. But this is the exact value, so we want the square root as part of the answer. All right, now we make it a word problem, which for some students, like, oh man, why do you have to make it really hard like that, right? Okay, it's not meant to be. It's just now it's words. So you may have to draw your own picture of a right triangle. The shorter side of a right triangle is 13 inches long. The difference between the lengths of the other two sides is 1 inch. Find the missing sides, use exact values. Okay, so this one is a little bit different than I thought it was. But again, a picture may be helpful. So let's see. Let me use the technology, because when I draw stuff, it sucks. Well, that wasn't as good as I thought it was going to be either. Let's not fill it. There we go. So there's a right triangle. Is that a good one? I don't know. Is it proportional? I don't care. So what I do know, though, is that the shorter side of a right triangle is 13 inches long. It doesn't matter which side I make it. It just has to be one of the legs. The legs are always shorter than the hypotenuse, which I probably should have mentioned. But remember, the two sides that make up the right angle, which isn't shown here, are the legs, which I'm showing in red. But right now, one of them is 13. Now, the problem here is that it says the difference between the other two legs, which would be the hypotenuse and the other leg, is 1 inch. All right. Now they're different lengths, so I'm going to say this is the one length, and then I'll do h for hypotenuse. Okay. So what it's saying right there in purple is that if you take the hypotenuse and subtract the other leg, you'd get 1. All right. So almost like a system of equation. I'm kind of looking to replace h with a expression. So I would solve this by adding x to both sides, so I can just have the h, right? So zero that out. So the hypotenuse then is just, I'm going to say is 1 plus x. You can say x plus 1, doesn't matter. And now instead of showing an h there, we could, if we wanted to, show as 1 plus x or x plus 1, doesn't matter. Why is that important? Because now that I have the hypotenuse in relationship to x, which you could have, if you wanted to, you could subtract h from both sides and then divide both sides by -1. Then you would have this leg in relationship to the hypotenuse. So I'm using specifically the shorter side here, the leg. Okay, so one of the legs, I'm going to the Pythagorean theorem. One of the legs is 13. The other leg is just the x. And then the hypotenuse, right now for me, is 1 plus x. So if I take those two legs and square them, add them together, then I would have the hypotenuse altogether squared. It should be equal to that. So we can see that we got a binomial there, which is being squared, which we will have to square, which will then give us a trinomial. So maybe the x plus 1 would have been a better option. It doesn't matter. So 13 squared is 169. And then plus x squared, no problem. Plus x squared equals, over here, 1 times 1 is 1. 1 times x would be 1x. X times 1 would be another 1x, which would combine to be 2 x's. And then x times x there is x squared. Now, some students would, at this point, switch those up so that it looks like a standard form or descending order trinomial. I'm not going to do that, just because I don't want to yet, but I'm going to eventually. So what I'm going to do right now is I want this trinomial to equal 0, right? So I've got to get rid of that 169, so minus 169 from both sides. So it's a negative 168. But also, we'll have to minus the x squared. So you see right here, this is nice because it zeroed out that x squared, but also it zeroed out this one as well. So I can drop my positive 2x's. Well, that equals 0. I thought I was going to have to do some factoring here, but I no longer have to. So I got to move that sucker back. The 160, I'm going to move the 168, the negative 168, so I'm going to add 168 to both sides. That'll zero that out, so I got 160.
It wasn't wrong, though, that you had to move it back.
Probably would have noticed, but I didn't. So then I can drop my 2x there. So here we go. This equation, one last step to solve, divide both sides by 2. And x, we know x, from the diagram, x is representing the leg, right? And then 168 divided by 2 is 84. This was all in inches, so that should be in inches. So that small side length right there, that leg, should be 84 inches. And then down here, we know that the hypotenuse is one more than that, so over here my hypotenuse, I know should be 85. Now, some students are like, well, I don't like just leaving a chance like that, which is good. I don't want to either. So we can check, right? So we can go back to the Pythagorean theorem. We should have 13 squared plus 84 squared plus 85 squared, or equals 85 squared. It should be equal, okay? So let's see, 85 squared. Oh, that's a big one. And I got 7,225, and then 13 squared plus 84 squared, 7225. So that is true. And now I can feel a little bit, at least a little bit more confident about my two answers right there. Recall that laptop computers are measured according to the diagonals of the screen. So a 16-inch laptop has a screen that is 9 inches tall. How wide is the screen? This is kind of like the first problem that we did. Let's see if some technology will help us. Let's say that's the computer screen, and the diagonal is what that would be how they, I guess, this one. So when they say it's a 16-inch laptop, that's the diagonal. Now, why is that important? It's because this right here is just the, it's just the triangle we're focused on. We don't really care about the rest of the screen right here. Now, I'm using this part of the triangle just so it looks similar to what we have been doing. But you don't have to. So that's a 16 inches. Now, it said it had a height, though, that was 9 inches tall. Make it this one. So I have the hypotenuse, and I have one of the legs. I'm missing this leg right here. I'll just use x right there. And so I've got, crap. I got x, and then I got 9. And then the hypotenuse is 16. So the two legs, square those, add them together, should be the hypotenuse, also as a square. So, in my calculator is 16 squared. I'll start with that one.
Wait, I'm confused.
All right, so I got 16 squared, 256. 9 squared, I got that one is 81. So x squared plus 81 equals 256. Kind of going into the words right there, but minus 81 from both sides. That zeroes that out. Now I got x squared equals 256 minus 81, 175. All right. Now in my calculator, when I put this in, because I'm going to square root both sides, it'll give me the exact answer. So if you just type in the square root of 175, it simplifies it for you. It shows me as 5 times the square root of 7. Now, this is a word problem, though, so your 5 squared is 7. Make sure you label it in inches. Okay, now this is the exact answer because it has the square root in the problem. In order to make the calculator make this a decimal, I'm just going to go right above the enter is the double arrow button. If I push it, my calculator says, oh, you wanted 13.228755656. I don't because it didn't tell me where to round, but I'm going to round to the nearest hundredth. So my 2 right there, the 8 is going to add 1 to the 2. I have 13.23 for me. You're welcome to round it wherever you want. Hopefully the tenths, maybe. But I wouldn't go past the hundredths. Sometimes, if they do this on the assignment, they'll usually tell you where to round it, but they didn't right here. So.
Can you tell me now, because what I put.
All right, the distance formula is the Pythagorean theorem. What the crap are you talking about? Well, here's what I mean. All right, so if you look at two values, let's I'll go right here. What is that? That's negative 6, 7. Okay, so negative 6, 7. And we'll come way over here. I'm going to make this triangle kind of big. So we'll come over here. And that's at 3, negative 6. Now, we're looking for the distance between these 2 points. See if I can use some technology to help. So that would be these 2, right? But this right here is actually just the hypotenuse of a right triangle. And some students say, well, where's your right triangle? Here it is, okay? So you can make this side length right here and this one.
Did you just make these?
Now, if you can find the lengths of these sides, then you can use the Pythagorean theorem, right? Where you got a squared plus b squared equals c squared. I'll throw that in. A squared plus b squared equals c squared, right? Leg squared plus leg squared is the hypotenuse squared. And so you could find that right here, well, in fact, I'll use different colors. But this leg right here, see how it's up and down? That's kind of like the change in y, right? It's a difference of y's. I apologize. It's a difference of y's because difference is distance. Now, why is it the y's? Because it's straight up and down. So what I mean here is that you take the 7 and the negative 6, and we could say that's the first leg, right? So you could say 7 and negative 6, you'd just minus those, and you'd get 13 right there. Now, is that generally how you would do this on a graph? Probably not. You would probably just count, right? And say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You'd probably just count the lines. But they won't always give us a graph. That's why we're using this minus stuff. But then you have this part right here on the bottom, this leg right here, and that's the difference of x's.
So it's 9, right?
So yeah, so this one, right, so you take the x's, you got negative 6 and 3, so it'd be negative 6, and again, it's minus because it's a difference at distance, negative 6 minus 3, which is negative 9. Now, you'd usually just count this and say 1, 2, 3, 4, 5, 6, 7, 8, 9, and you'd say well, it's just 9. It doesn't matter that it's negative, or if you made the 13 negative, it wouldn't matter, because what we're going to do is we're going to take these, and we're going to square them, and a negative squared is still going to be a positive. So that's a 169 plus 81. It's going to be 250.
Which point we choose to subtract, whatever it is.
Now, if this was slope, direction would be important, right? Negatives and positives, but this one is not slope, so we don't care. Well, it shouldn't turn into slope yet, but you could look at it kind of like we would with slope. And then you'd solve this, right, by just taking the square root of these two. 4, 8, 10, so that'd be 5 root, not 10, 4, yeah, 5 root 10 equals c. Okay, so that means the distance here would be 5 times the square root of 10. What is that rounded? I don't know. Also, I don't give a crap. I was just trying to show you guys how this works. Now, the main thing right here that I was also trying to show is that we're looking at differences. So when you see this formula right here, see how they're taking the x's? I know I did the y's and then the x's. Doesn't matter. Okay, so you can do the x's and then the y's. You can do the y's and then the x's. Doesn't matter. It's just the distance between your x's and the y's, which is just another way to count, kind of like we had before, right? Okay, so again, this was 13, and this was old 9er. But if you have a graph, you can just count, okay? But if they don't give you a graph, they're just going to give you 2 ordered pairs. You got to plug them into this equation, which there's different ways to show it. And what the heck? And so if I had like negative 6, 7, this is the way that I would show it. Not that you have to. But here's what I'd do. I'd say, well, from 7, I'd go down to negative 6. That would be down 13. And then from negative 6 to 3, that would be to the right 9. And then you see, this is another way to find those two leg values right there. Whatever. I'm still going to end up using the distance formula on these just so that you can see it. But there's lots of different ways to find these lengths. If they don't give you a graph, by the way, and you prefer to see it on a graph, put it on a graph. I don't care. You're going to get the same values either way. I'm going to keep the distance formula on here so we can see it, right? And this first ordered pair, you got a x1, y1. Now, this one's showing x2 minus x1, y2 minus y1. I don't know why math nerds did this a long time ago, but they did. They did 2's minus 1's. I kind of like to start with the 1's, but I'm going to stick with what we got there. So x1 there, boom, is 10. And then the y value, its corresponding y value is 4.
Did we finish the previous?
And then we have x2, y2, which I'll do in purple. So the x2 is negative 3. The y2 is 3. Now I'll just fill in everything else, right? And in fact, all this stuff, see if I can do this decent. All this stuff is, you can put this directly into the calculator as is. So yeah, square root of 170. Again, you see that they've taken away the graph from us. No problem, we just plugged it in. And again, this is, I would just stop right here, put this in the calculator. I actually wouldn't show this work right here because it's faster just to put it, this whole thing into the calculator and then do it part by part, but it's up to you. Formula is, so this is the formula right here, but you see there's no square roots, which is nice. Why are they dividing by 2? Why are they adding this time? So you see in the distance formula, they were doing subtraction because it's distance between the x's and the y's. The midpoint formula isn't, this is an ordered pair right here. That's why we've got the parentheses and then the comma between it. It's an ordered pair for x and then y. Since they're adding the two values and dividing by 2, this is an average for both of them. So the average is the middle of your x's and the y's. So if I were to look at an example, I'm just going to, again, I'm just putting these points on arbitrarily, just made up. So this one is negative 6, 3. And this one, what the heck? We'll do this one at negative 2, negative 6. All right. So with this, I really don't care that it's a right triangle because I don't really care about the hypotenuse on this. If it matters to you, you're welcome to put it on there like I did, but I didn't have to. So here's what I would do, at least if I had a graph, right? Is I would look at these two values, how far apart are they? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're 9 apart. But I got to go halfway in between, right? So that'd be, I'd just divide that by 2, which would be 4.5. Okay, so that'd be 1, 2, 3, 4.5 right here. So negative 1.5. And that would be my, that says y, negative 1.5. Again, this 4.5 is, you can count from the top or the bottom, and then wherever you end, that's where the middle is. I may be overcomplicating this, which if I am, I apologize. But for my x's here, this is 1, 2, 3, 4 apart. So halfway would be 2, which is at this value of x, which is negative 4. So I would end up with the ordered pair, negative 4 and negative 1.5. Now, this is doing it with the graph, and you can kind of use this. I guess this is a more of a direct method. But if you were to plug these values, these x and y and this x and y into the formula, it would get it for you. And we're going to need that because they're not always going to give us a graph. But if it does help you to do this on a graph, do it, because the graph it's a legitimate way to do this. But you can see, again, we're always dividing by 2 because we find the distance between the points and then divide by 2 so that we can see how far the middle is. Again, this 4.5 is just how far the middle is, not where the middle is. It's not y is 4.5, which would be way up here. It's how far from the edges it is. Let's just do it.
Yeah,
What the heck?
it's, minus 4.
You knew where we were headed.
Minus 3 half.
Yeah, well, we got the negative 6 and 3, and then we got negative 2 and negative 6. So again, if you put this into the calculator, what do you get? As it turns out, -4 and -1.5. Okay, so again, this ordered pair right here, which is, let's see, where is that? -4, -1.5. See how it's right on that line right there? If I can do that right. -4, -1.5. If I had drawn that line better, it would be, there we go, that's better. But that's the ordered pair, -4, -1.5. So it should, the midpoint should be on the hypotenuse. I just don't care about the length of the hypotenuse on this. I don't care at all, so. Now again, if you're like, you know what, I'm better off just putting this on a graph and doing it, do it, okay? But since they're not giving me a graph, I mean, I could put one on here, but let's use the formula. Now, the divide by 2 and the addition is always there, okay? Because again, we're adding because we're finding the average. So we got a x and a y value in red, so that would be 3, 5. And then we got an x and y value in purple, which is -2, -5. Now, again, for me, I would just say, look, just please put this in the calculator. It's going to help you to avoid making mistakes, which I usually do. Let's see if I do right now. So in the x's, 3 plus -2 would be 1. And for the y's, 5 plus -5 is 0. If I were to simplify this, then I would get 1/2, 0. That is my midpoint. I know you guys wanted more square root stuff and solving and some systems of equations with 3 variables. This is what you get. This is all you get. On this graph, again, we got the formula right here. But for me, I usually just say, hey, just look at the graph, right? So I see right here, right, we got this leg, and then we got this one right here. And I can see the midpoint between those two is 4, right? Now that's a 4, that's a y value. I'll put it down here. Okay, so for my final ordered pair, I should have a y value that's 4. And then for my x's, I see those are 3 apart. Right in the middle is this one, which is at 2.5. 2.5 works. If you want to make that 5/2, that's fine, but 2.5 should work on the assignment too. Well, what if we don't want to use? What if we don't want to use the graph? Well, use the formula then. Okay, so the 2 ordered pairs, right? We got this one right here at 1, 5. So I'll make that the first ordered pair, 1, 5, and then we got this one right here at 4, 2, which is at 4.
3.
Oh, well, I was fairly close. It only took me about 2 hours to make that first mistake. That's not bad for me. So now we got this would be 5/2. Like I said, you could make that 5/2 there for the x value. 4 plus 1 is 5, and then just divide it by 2. If you want to keep that as a fraction, that's fine. I saw that on the assignment. It'll accept both. And then 5 plus 3 is 8/2, which is, well, that's 4. So 8/2 won't work, but 5/2 will. So 2.54 or 5/2, 4, will work as your ordered pair for the midpoint, yep. And again, we should be able to see that, right? So the midpoint,
And I suppose we have to
2
put
and a half,
parentheses around it
5,
'cause it's an ordered pair.
there it is. Yes. Yeah, do not forget the parentheses for ordered pairs. Yeah, that's a good point. It's not such a common mistake, but it does happen from time to time where students put the 1 here and the 5 as the second value. Yeah, if you're gonna make the 1, 5, make them the first, or if you wanna do 4 3s, do that first and then 1, 5 second. You'll still get the same value, and it's okay to switch them as long as both of them are switched. Right. So the midpoint of AB is 0, -5, and A is 310. Now, I personally would not use the formula for this. I'm still going to use the formula. Still going to show you how to use the formula. But, in fact, let's use the formula first, okay? So we know that one of the endpoints is 310, all right? So in our ordered pairs, I'm making this extra wide on purpose. But this would be 310, right? What we don't know is the ordered pair for B, so I'm just going to use an X and a Y there. X and a Y. But what we do know is that their midpoint values are 0 and -5. So this X would be 0, and then this Y's would be -5.
Wow.
Okay, and then what we have now is two equations that we're going to solve for x and y, the new x and y for the endpoint B. All right, now I'm just going to solve these like I would a regular equation. So I'd multiply both sides by 2 on both of them. Okay, so that'd give me 3 plus x equals, well, 0. Right, because the 2's are going to phantom 1 out. And then I'd have a 10 plus y equals negative 5 times 2 would be negative 10. And then, well, on this one here, I'm going to subtract 3 from both sides. So the x equals negative 3. And over here, I'll subtract 10 from both sides to zero that out. So y equals negative 20. And of course, this was in the ordered pair. But let's write this as an official ordered pair of negative 3, negative 20. Okay, that's the formula. How would I have done this if I was to do this without the formula? Well, I would say, well, point A is at 310, and then the midpoint is at 0, negative 5. What I'm trying to find is my ordered pair for B, right? So you got A, you got your midpoint, and then you got B. Well, for my x, I can see from 3 to 0. For my x, that'd be to the right 3. So since that's the middle, I'd have to go another 3 over to the right to get to the B. Sorry, that was to the left 3. I had to go down left 3, and so I'd have to go left another 3. That'd be negative 3. Now for the y's, from 10 to negative 5, this would be down 15. So from negative 5 to the new endpoint, I'd have to go down another 15, which would be negative 20. And you see we get the same endpoint, just in a different way. Same thing.